This is a game that we call Crystal Maze, and this is how it works. So we've got to imagine that first of all, we're going to be moving through this maze. Now, you need a person who knows the way through the maze. So they've got the map, and they're, if you like, um, facilitating the game. Now, the players, they've got to imagine that they can move like rooks, but they've got to take kind of one step at a time. And so that means that they can move to the left or to the right. They can move up or down, like just as a rook would move. So right, left, up, down, as we can see it there. And of course, that means that they cannot move diagonally. That's the idea. And each time they make a move, and to make a move, they'll choose a card that will be the next card in the path. Then they are told whether it is correct or not correct. And the idea is that they've got to learn the path through that means by making tests and seeing if they're right or not, and then learning those tests. So this is a really nice way to kind of show quite a good model for doing STEM-based activities. So let's have a go. If we start, we'll choose a card. Now, that's the card that we choose, and then there has to be a decision as to whether that's the right card for the first step or not. And if it isn't, that person would join the back of the line, and then the next person would have a go. And the next person will choose their starting card. This is the first card in the maze, let's say, and again, they'll be judged. If it's not the right card, they'll move to the back of the line, and the next person will have a go, and this carries on until somebody gets the right move. Now, of course, this person now has two choices. They're going to have to get their next card, and they can either go to the left in this case, or they can go to above. They can go up or forward, and that's because that happens to be the corner card. Other cards would have more options, and then they're going to have to choose one of those. So they get their next turn, and that will be judged as well. So if they go to there, that's right. Then they've got the second card in the path, and then they get to have another go. And they can check that. That is also right. They get to have another go. And they step there. That is correct. They get to have another go. They step there. And they keep going until they are incorrect and they've chosen a wrong step in the path. In which case, they go back and it will be the next player's go. And the next player has to start from the first step again. So, and they'll go through the process. Each step they wait. Now, and they can't miss a step either. So in that case, a step was missed. So that will be incorrect because that's not the right third step. It's the right fourth step, but it's not the right third step. And so they would go to the back of the line. So each time a person has to go through each of the steps and they learn the path that way if they're paying attention to what other people are doing. And each time they get something right, they move further through the maze, and those who are kind of paying attention get to know more of the steps. And yes, there we go. Now, this is an interesting position because from this position, there's really only one way that you can go. Now, strictly speaking, no, because you could have, let's have a look at the path so far, actually. So this is the path so far. And there's nothing stopping the path from going this way, but it then can create a bit of confusion here, which might not be necessary to create. So we'd suggest that we don't choose that as a path, and that means, of course, there's only really one way to go, which would be that way. And that's fine. It's nice to have that in there because it's still a logical jump that people have to make to do that, so that makes it useful. And the goal is to get, we've kind of not gone very far from what we'd call the start here, but the goal is to get all the way through the maze. And usually I'll have a set number of cards that I'll use, and that might be 15 or 20. And the player then has to get to the very end somehow and get the right card that's the end. Find the right card, and then when they find the right card, they can move through or step off into having actually completed the maze. There's not enough to get to that very last row. You've got to decide which is the last card, and that's often why knowing how many cards there are is useful, and then people have to use that number to work it out. So that's the game. That is our crystal maze, and we'll show also a way, because we're using the cards for this, we'll show a way that this can be done so that we get a puzzle that you can give people that not only teaches them the maze but gets them to do some other kinds of logical thinking.